Okay, welcome back to Easy Physics. Here we go. Let's do it. Consider the following circuit. Boom, there's a circuit. It's so beautiful. At what rate does the battery deliver energy to the circuit? All right, well, that's easy. So at what rate does it deliver energy? That's talking about power. Power is equal to I times V. Well, we know the V of the battery. The V is 120, but got to figure out the I. So to figure out the I, we have to figure out the R. So to figure out the resistance, we're going to have to look at this circuit here and calculate the resistance. Okay, so let's see. We're going to add up these guys first. The 20 and the 100, they are in series. So they have 120, and that's going to be in parallel with the 40. So 120 reciprocal plus 40 reciprocal enter. So we got 30. Now that 30 is going to be in series with the rest of them. So you have 40, 50, 60. So the resistance is equal to 60 ohms for the whole enchilada here. And we know that V is equal to I times R. So R is equal to 60 and V is equal to 120. So that means that I is going to equal 2. Nice. So at the end of the day, P is equal to IV. I is 2 times V is 120. So that means you're getting 240 joules per second, or watts, whatever you want to do it. Nice. Easy money. Doing the next one. Find the current through the 40 ohm resistor here. Okay. So we know that this guy has a current is equal to 2. That means this guy has a current is equal to 2, and this guy has a current equal to 2, and this guy has a current equal to 2. With all of that in mind, we know each of their voltages. Voltage is equal to I times R, so this is going to be 20. V is equal to 20 for him, and these are all the same. V is equal to 20. If I talk about this loop here has to add up to 120. Well, if I got 120 and I've got 20, 40, and 60, that means the voltage for this guy is going to be 60 because it's got to add up to that 120. Well, since I've got all the pieces here, so let's see. V is equal to I times R, so I've got 60 volts is equal to I times 40. Divide, the I is going to equal 1.5. So that's the current through the 40 ohm resistor, 1.5 amps. And we'll put it in the chart here. Nice. Determine the potential difference between points A and B. Okay, well that's easy because we've already done it. A is up here on this guy, right? B is on this side. Remember, since they're connected, wires are free. So what's the potential difference? Potential difference just means voltage, so it's going to be 60 volts. At which of these 2 points is it higher? So there's 60 between them. So which one has the higher potential? Well, it's going to be A, because it's on the positive side of the battery. So remember, this guy is at 0. This one is at 20, because we passed through the 20 there. And this one is at 80 volts, because we went up by 60. All right. Ta-da. All right, let's look at D. Given that the 100 ohm resistor is a solid cylinder that's 4 centimeters long, opposing material's resistivity is this. Determine its radius. All right, easy. We've got a formula for that. So looking at your formula sheet, we can remember, hopefully, that R is equal to rho times L times A. Nice. Now, rho isn't density, rho is resistivity because it's the version of R, the Greek version. This should make sense. The longer it is, the more resistance. The wider it is, the less resistance. So we know that it's got 100 ohms, and we know the resistivity is 0.45. We know the length is 4 centimeters, so remember to change that to meters here, like good people do. And determine the radius, well, it's a cylinder, so let's just go ahead and put pi r squared, and we're going to solve for r. So r is going to equal the square root of 0.45 times 0.04 divided by pi divided by 100. And we got to type this into our calculator real quick. So 0.45 times 0.04 divided by pi and 100, close parentheses. So I'm getting a radius of 0.0076 meters, or 7.6 millimeters. And it wants a radius, right? Nice. That's it. All right, one more. With resistor, which resistor or resistors, if any, could be replaced with a capacitor so that when the capacitor is fully charged, no current flows in or out of the battery. Okay, so remember, when full, a capacitor has no current. All right, because it's totally blocked off. So if you were to take scissors and cut which ones of these would completely destroy the circuit? Well, let's take the easy one first. This guy. If you were to break the circuit right there, boom, it'd be gone. Same with this one and same with this one. For these ones, though, if you cut this, the number 40 there, the current would go around this way. And likewise, if you cut the 20 or the 110, the current would just go through the 40 that way. So it's the 10 ohm resistors. What are the ones that you could replace with a capacitor so that it stops the flow of the battery? And that's it. That's the whole thing. That's all they want. Nice. Let's keep going. Consider this circuit. So wonderful. What's the current through each resistor? All right, we can do that. That's not so bad. Okay. So we know this guy's current right here. So we have his current. So we have to figure out his voltage. So we're going to basically do this for all of them. All right. So this guy, V is equal to IR. This is the formula we're going to be using all the time here. V is equal to IR. V is equal to I, which is that, times R, which is that. So it's going to be 30 volts. What do I know from there? I know, because these three branches are in parallel, that the 60 ohm over here is going to have the same volts. The same volts is going to be 30. Now, since it also has the same resistance, I know it will have the same current. Okay, what else do I know? Now, I know that the 20 and the 40 are going to have the same voltage together. Okay, so and the 20 and the 40 together have 60 resistance, and I know they're going to have 30 volts. So that means that they have to have the 1/2, the 0.5 current. So I is equal to 0.5 for both of them. But they're not going to have the same voltage, but together their voltage is equal to the 30. So this guy has a voltage of 20 because 40 times 1/2. This guy has a voltage of 10 because 20 times 1/2, and it adds up to 30. Nice, nice, nice. So the last bit here is I, for him, is going to equal the three pieces together. You got 1/2 plus 1/2 plus 1/2. So you get 1.5 amps because all together it equals 1.5 amps. And it didn't ask for it. Oh, it's going to right here, right after this. So for voltage, I times R, so you're going to get 15 volts. All right, so that helps you with the current and the voltage through each resistor. What is the equivalent resistance of the circuit? Okay, so we're going to figure out the big R. So what we got to do, I suppose there could be other ways to do this. Let's just do it this way. We have 60, 60, and 60, right? So we got to do reciprocal adding for those. So we're going to do 60 reciprocal plus 60 reciprocal plus 60 reciprocal, enter reciprocal, enter. So you get 20 for the bottom box. So you're going to have 20 plus 10, which is equal to 30 ohms. Other way you could have done this real quick, because full disclosure, V is equal to I times R for the whole circuit. The whole circuit has a voltage from here to here of 45, right? 45 is equal to I. What's the current going in and out? 1.5 times R. Well, what's R going to equal? R is going to equal 30, just the same way. We just wanted to show you, just in case, who knows what they're going to do on the AP test. Really. The rightmost 60 ohm resistor is replaced with a fully charged capacitor. So we're swapping out that one for a capacitor. Nice. When the capacitor is empty and just beginning to fill, with the current, will the current in the leftmost, so now we're talking about him. So this is a capacitor. So will this guy's current be greater than, equal to, or less than the 0.5 it was before the capacitor was inserted? Well, what's going to happen? When the capacitor is empty, the current's going to flow this way exclusively. So it's going to be less. There's going to be no current at all. Initially. It's going to go up afterwards, but it's going to be basically zero. Okay, when the capacitor is fully charged, will the current in the leftmost be greater than, equal to, or less than before? Well, when it's fully charged, it's like nothing is here. It's just blocked off. So now the 1.5 is coming in. It's going to be splitting off into only two pieces. So this is going to be more. The 1.5 splits into two equal pieces, so the current is going to equal 0.75 amps. All right, so that's going to be more. And that's it for circuits. Easy money. Hope you had fun. Like and subscribe.